my friends of Atari Labs, welcome to this tutorial. In this tutorial we are going to do a practical exercise of geospatial crop counting from drone orthophotos with Python and Scikit Learn. Okay, so how we are going to do that? This is the result of what we are going to do. There is a previous tutorial where we decrease the resolution of the drone orthophoto because it has a resolution of 3.5 centimeters that actually we have changed it to a resolution of 14 centimeters. Otherwise the process will be really heavy, okay, and the results won't be better as well. Okay, so let's start. You are going to receive in the description of the video a folder that will have this, and this. Okay, the folder where you have a raster file that is this one. Okay, I'm going to delete this. Okay, you will have this orthophoto with a resolution of 14 centimeter. Okay. Okay. Sorry, something is going on here. Okay, I guess that you were connected. Okay, so and I hope that something went on in my computer. So let's go on. Okay, so you are going to receive this orthophoto and this shapefile. Okay, and the shapefile is just a normal shapefile of points that are at the center of selected palms in this case. Okay, so and then you can do your own selection. I mean, you can do your own, you can place it in the plants that you like, and in this case we have 14 plants, but for you can have maybe 5. I mean, it's really up to you. You can play around with that. Okay, let's see. What we are going to do is, okay, we are going to do all the process in Python with the raster, Scikit Learn, Scikit image, but the results will be geospatial. Okay, so you will have at the end, you will have a shapefile. Okay, so let's create a new notebook. Okay, so in the notebook, what we are going to do is we are going to import the required libraries, that is Matplotlib, GeoPanda, Raster, Scikit image, and actually Scikit image, and then after I import Scikit Learn. Okay, but Scikit. Okay, so and then we open the shapefile, and for us it's really important to open where with GeoPandas we open the point data and then the orthophoto, and however it is really important that we have both on the something is going on. Yes, let me, yeah, because those are here, so I actually have to eliminate from the car, otherwise I cannot kernel from all cells. Let's see if this works. Okay, I know what is going on. Sorry, because I have created on the txt folder and that's actually not here, so it has to be here on the root zone. Okay, so I say new factor. Okay, here. Okay, so we import the required libraries, and then we import the shapefile and the orthophoto, and it's important that the orthophoto is on the same system of reference, otherwise it won't work, and we are working in QGIS 84 geographical coordinates. Okay, and then we have a orthophoto of 4 bands that has the red, green, blue, and alpha and transparency. Okay, so we can plot our orthophoto and our points to see. I mean, and this is the same visualization as you have in QGIS. Okay, this is the code, and then you can plot it, and this is really nice because you can explore your spatial data with you can explore your geospatial data with Python. Okay. And then we are going to select a band in order to do our analysis, because the analysis is actually on a band. It's not the analysis is not on the 3 bands. Okay, so yes, we select that band. In this case is the green band. Okay, and then we are going to extract is okay from the position. We are going to extract the row and column of the in the raster band of the different points. Okay, so these are, and there are 13 points, and these are the position, the row and column. Okay, and then we are going to specify a ratio, and this ratio is based, and this ratio is mostly related to distance. Okay, so we are going, our analysis will be from the center 25 pixels in this direction, in this direction, in this direction, and in this direction. Okay, great. And then what we are going to do is we are going to show all the, for the 13 points, we are going to show which will be the image that we'll be using for our match template. So these are the images that we are going to use, and the code will look for this image in the whole raster, and if the image match with this one or something similar to this, it will provide us a value. Okay, a value of 1. If this is the right image, it will have a value of 1. Okay, so but sometimes, since this is kind of a the shape is kind of a star, we can have something similar but rotated. So therefore we have for each of this image, we are going to rotate them. Okay, and then we are going to rotate because we can have a similar image but rotated. Okay, so with this code we are going to rotate, we are going to have the first one, then rotated 30, 60 and 90. Okay, and then you are going to see this is the complete set of image that will be, those are the images that will be set. Since the resolution is 14 centimeters, this process is actually not so long. Okay, because at the beginning it was done in the resolution of 3.5, and it was really computing, it takes a lot of the resources. And the results, in my opinion, were not the best. I mean, but you can do it with a resolution of 5 centimeters and see how it goes for you. Okay, then we are now we are working with each image. Okay, and then we are doing the matching. This can take up of 2 minutes. Let us present ourselves. We are Hatari Labs. We are a blog dedicated to knowledge sharing in Python, in water resources. We like what we do. We have e-learning. We have a blog that is Hatari Labs. Okay, this is our blog. We are posting a lot of tutorials. We have a newsletter, and then we have a Facebook, Twitter account, and then we support ourselves by selling our courses. There are some common courses in Python for hydrology, and there will be another courses in well, mostly groundwater modeling, but this topic maybe we will look for a webinar on that. We have an e-learning platform where you can access to our recorded courses. Okay, for example, this one or this one. Okay, and then payment is through PayPal. Okay, so let's continue with that. Now, for the people that are watching this live, I'm really happy that there are 2 people to see this live. So thank you. Okay, and there is 1 like, so well, great. So yep, it has finished. and then we are going to see the points that has a higher reference, it has that are close or that has a high template factor, okay, high match factor, okay, so they are similar, okay, but this is a point cloud because, okay, because this is not exactly one point, okay, there are many points that fit in this classification, okay, and then we need to do a cluster analysis, and then we are going to select a Birch analysis, okay, and this threshold is related to the position, but in geographical coordinates, okay, if you use UTM, you have to change this to meters, okay. Okay, great. And then what we are going to do here is we are going to run this, and then and these are the values of the clustered, and then here, instead of having such a cloud, we only have one value, and there are some points that there are some mistakes here, and there are even some vegetations that were not mapped or were not identified. I did many trials on this, and in my opinion, well, it's not that bad if you just place it. You just, as a shapefile, you just place this on the hand because there are few. Okay, and then if you will see on this, there are palms, but the shape of those palms are really different from any other. Okay, so and this is really hard for the computer to understand that there is a palm there. Okay, and then finally, because this is just a NumPy array, what we are going to do is we are going to save as a CSV array. Okay, and then with the save as a CSV array, we can import this in QGIS. Okay, so here we can import this, and these are the birch point that were just created here. Field 1, field 2, and this is in geographical. Add, close, and then we can zoom to layer, and then we can change of apply, and these are the we can also plot this. This is just this. Okay, so these are our the input plans, and these are the interpreted plans. Okay, there are some mistakes on the border because I don't know, of the match template on the borders it gives higher coincidence, and I don't know why. And as well, the road has a reflectance that also trick the match template. Okay, but you can delete this easily. Okay, and okay, with some with some manual filtering you have already this. And let me tell you that this palm is kind of a intermediate level, or maybe it's complex level of plan interpretation because it's highly irregular. Okay, so this was our tutorial, and I hope that it was helpful for you. Thank you for following us in this, for the people that were following the streaming. Give it a like, subscribe to our YouTube channel. If you want to see more of our streaming, I think that there is a bell where you can subscribe to see our latest news. Okay, so thank you, and see you in coming